All right, let's get this started. Let's first start with, hey, how do I name a triangle? Well, it depends on the information you have. If you know something about its sides and know nothing about the angles, the only thing I know is something about its sides. First triangle, if I look at it and say, oh, all three sides are the same length, I call that an equilateral triangle. Yes, equilateral. So we'll start there. That's disgusting. Or I look at it and I see, oh, two of the sides are the same, but the third one is different. That's referred to as an isosceles triangle. All good spelling words here. Isosceles. Or maybe I just look at it and say, oh, they tell me all three sides, but none of them are the same. That's called a scalene triangle. Okay, scalene if none of the sides are the same. All right, great. Well, what happens if I know none of the sides are labeled for me, but the angles are? We can also name a triangle by its angles. So here, all these arc marks are telling me what? All three angles are equal. Now, could I call that equilateral? Yes, because if all three angles are equal, so are the sides. But let's give it a more official name. If just I see the angles, equiangular. Equiangular. And let's take this a step above. What's each angle then? What's the measure of each angle then? 60, 60, 60, because they all add up to 180. So yes, equiangular and equilateral can be interchangeable. Next one. What if I just look at it and I have a 105-degree angle there? I don't care about the other two. I don't need the other two. Just as long as I know that's 105 bigger than 90, this makes it obtuse, yes. If a triangle has one obtuse angle in it, good enough for me. The whole triangle's obtuse. And then down below, this is one we've already used in the past. That's a good old right triangle. And then my final one, I have 70 and 30. Yeah, we could find the other angle, which would be, let's see, I got 100, so that leaves 80 left over. So if all three angles are less than 90, this is an acute triangle. Yes, acute triangle. All right. Yeah, we don't have much today. We do not have much today. All right, here we go. I give you some information, and you see some vocabulary term right off the bat there. M's the midpoint of JL. Great. What type of triangle is JKM? Can everyone just locate JKM first? Because there's three triangles in that diagram, and I want to make sure we're talking about the same one. JKM. Triangle, as you can see, triangle's always named by its three vertices. So JKM. This is the triangle I want you to tell me, is it equilateral, isosceles, or scalene? Well, I hate to break it to you. We're not going to do that right now because I only know one side is 0.75. I need your help finding the other two sides. Let's first start with point M is the midpoint of JL. If that is the case, how long is JM up here then? How long is JM? Get my numbers out. 2, 8. Boom, 27. How long is JM going to be then if M's the midpoint? 0.75, yep. So 0.75 here, which would also mean ML is 0.75, right? Two congruent segments. All right, I got two sides down. Anybody help me find KM now? How long is side KM? Woo, 15?
Why?
Why?
Because there's congruent marks on that line,
It was given that ML and KM were congruent by the hash marks. All right, now I know all three sides. Tell me what type of triangle I'm working with. KJM is one equilateral. So take a look. Triangle. We could start using that as an not an abbreviation, but as a symbol. JKM is equilateral. And it also says explain. So because, you guys help me out. What would be your because here? 5, because all three sides are, I'm going to use a fancy term here, congruent. All right, there we go. One down. Any issues with that one? I love number 2. Kids fall into so many traps, and I just light them up when they do. What type of triangle is this? Two sides congruent. I'm telling you the two sides are there congruent, correct? And we need to set up something, an equation to solve for x. Is it mandatory that I have to use all three sides? When I write this equation, is it mandatory that I have to use all? No! Use what you need. And this also fires me up. Oh, I'm going to take all three sides, add them up, and set them equal to 180. Oh, you are? What's 180 for? Not the sides, but angles. So leave it for the angles. Don't set up all three sides equal to 180. Ridiculous. Embarrassing. All right, we're better than that in here. So set something up for me then. I don't need to use all three sides here. Tell me what I should set up to solve for x if those two sides are equal. 28.
4x plus 1 equals 5x minus 0.5.
There you go. You don't need to use all three sides because they're given to you. Get out of that mode. And then I'll give you a second, solve for x. When you have it, let me know what's the value of x. 9, when you're ready. 1.5. And some of us have to break this habit. X doesn't mean I just move on to the next problem. Read the darn question. Find the lengths of all sides of this triangle. So take your 1.5, plug it back in, find AC, BC, and AB. And if we're doing this right, two sides should be the same length because it said it was isosceles. So plug it back in and let's talk. All right, when you have them, give them to me. 17 when you're ready.
They both equal, AC equals 17, and then BC,
17.
I mean not 17, 7.
7.
BC equals 7.
Yep.
And then AB equals 12.5.
Right, two sides better be equal. Any issues there? The only reason I'm doing this problem with you is just to emphasize. 1, sides aren't equal to 180. And 2, just because all three sides are given doesn't mean you have to use them. All good. Before we get to the next one. The next one gives me so much joy. Why? Because it gets you so much misery. When you're unhappy, it makes my life great. Here we go. Go ahead and graph that one, please. I'll wait till everyone has a chance to graph it. Please make sure you graph the coordinates correctly. I had 3 people graph this incorrectly last period. Bad foot to start on. Make sure the x coordinate gets graphed first, yeah. Make sure you go on the x-axis for the first number. Label your vertices too. Label them D, E, F. Get in that habit. Label your vertices so you know which one is which. Make it into a triangle too. Little things, little things. Make sure D, E, and F are on there. All right, let's do this. Tell me what type, based on its sides now, based on its sides. So the final answer here is either going to be scalene, isosceles, or equilateral. What type of triangle is it? And we're not going to go, hey, you know what? Looks isosceles. Here, we're done. That's not how it goes. So to tell you if it's scalene, isosceles, equilateral, I'm going to have to know what each side length is. So I can tell you. How am I going to figure out what each side length is? Oh, here's how we're going to do it. We're going to dig deep from unit 1 and use something from there. How can I find the length of each of those sides? Using something from unit 1. Thank you. Yep, that's why this is giving me pleasure. Distance formula. Rehashed again. Don't use slope. It's distance formula. There you go. I'll spot you the D equals. What do you got for me? Okay, big square root, right? We got a lot of things to fit under that bad boy. Next, we're building here as a team. Look at this. What's underneath this big square root? Nick? Come on.
Are we doing for DE?
No, I don't want numbers. I just want the distance formula with no numbers substituted in.
X2 plus X1 divided by 2.
You're thinking midpoint.
Oh.
That's midpoint. Kyle, help your teammate out.
X2 minus X1 squared.
All in a parenthesis. X2 minus X1 all squared. You want to keep going or?
Plus.
Yeah, plus in between, and then you probably have the rest.
In parentheses, Y2 minus Y1 squared.
There you go. There's the distance formula. 3 times. One's we're going to do together. The other 2 you're going to do in your group. So let's make a class decision here. 21. You pick which side you want to find first as a class.
DF.
Which one?
DF.
DF? Let me just make sure I want it. Yeah, that's good. All right, DF. Here we go. Line segment DF, big square root. Let's do this one together. The other 2 are in your group. Give me the x coordinates I'm going to subtract for D and F. Ho, 1. Claire?
-9.
X coordinates. I want to subtract the x coordinates of D and F.
-9 plus.
Oh, where's the -9 coming from? D and F. D and F. I'm looking to subtract their x coordinates. So what are the x coordinates? What's the x coordinate of D? Okay, so -5 minus the x coordinate of F. Minus -8. Anybody going to flip out if I put +8 here? Is that all right? We're good? Minus a -8 squared plus, how about the y coordinates? 11.
We're gonna go 3
Yeah.
and 9.
Yeah, we are going to go that. Good. Squared. All right, I'm not assuming anything, that we all remember this and we're good to go. So I'm going to take it step by step. 3, right? Squared. 9. Plus -6 squared. -6 squared. Positive 36. Hey, look at my 2 numbers here. They should never be negative after you're done squaring. Well, my calculator, well, put it in parentheses then in your calculator. Because, yeah, hey, I don't have a time to go over the big discussion of why when I do that, that's -36. But when I do that, that's 36. Okay? Oh, you want to? Sure, we're in honors. Why not? You know what's being squared here? 6, and then they're putting the negative in front. Versus here, you're squaring the whole thing. So put parentheses in your calculator, please, if you're going to use it. All right, let's keep grinding. Do I take the square root of each number? No. I add them up. 9 and 36. 45. And anybody want to remind me, on your schedule, it says, what's the name of this class again? Darn right, honors. So guess what I'm going to have you do every single time? Simplest radical form, just like we did in Unit 1. So let's review that. How do I break down square root of 45? I break it down into two radicals. I am searching for the biggest perfect square that goes into 45 without any remainder. The biggest one. So 4, 9, 16, 25, 36, on and on. The biggest one that goes into 45 without a remainder or any decimals on your calculator. What do you got? What's good? What's the biggest one? 9. What do you have to multiply 9 by? 5. And this is why we pick a perfect square, so we can take the square root of it. So, square root of 9, 3. Square root of 5 comes along for the ride. There is DF, 3 radical 5. 3 radical 5. All right, you got the other two sides in your group, and I'll give you a little hint. One radical can be simplified, the other one will not be able to be simplified. So you just leave it. Go ahead, kids. Go ahead. And this is not you do this one, and hopefully we're correct. We do them all at the same time. If anybody wants to see where it came from, let me know. Let's start with, let's see, we just did DF, so let's do DE. All right, what did DE come out to be? Let's hear from 25. DE.
Radical. Yeah, 113.
Well, let's figure out how we got that other than somebody from your group. All right. Here we go. X coordinates. What are they? D and E. Let's do this out now. D and E. What are the X coordinates? Let's go. Yeah.
2 and -5.
So what'd you do? 2.
-5 or +5.
2 plus 5 squared. All right, keep going. What about the Y coordinates? 9 minus 1. All right, let's keep going here. What do we get underneath here? 7 squared.
49.
And here?
64.
Yep. This gives us our 113, which cannot be broken down. There is no perfect square that goes into 113. So we got 3 radical 5. We got square root of 113. We got one more to go, which is FE. And let's talk. FE broken down 2.
Square root of 104.
You didn't want to break it down? Here we go. Let's hop on that calculator. Let's find a perfect square that goes into 104. 100, it's not it because it's got to go in without a remainder.
Yeah, it's 10 remainder. No. Isn't it just 11 or 10? I don't know.
Okay, ready? Grab your calculator, Phoenix, because we're getting this done now. We're not getting it wrong again. 104. What's the first perfect square that we think of? I'm asking Phoenix.
100.
Why are you picking? Okay, watch. If I do 100, there's a remainder. It can't just be the biggest one. It's got to be the biggest one without a remainder.
4.
104 divided by 4 gives me 26. So what goes underneath my radicals then?
It'd be square root of 4 and the square root of 26.
Okay, let's keep going. Square root of 4.
2.
And what do I do with this radical 26?
Keep it.
For everybody else, if you are unsure if you made the right choice or not, everyone's got a calculator, correct? You take the original one. So the original was square root of 104. I take a look at the decimal. Then what you think your answer is. 2 square root 26. And you know what? They better match. Okay, that's how you can check. Because I know I got a lot of hardcore students in here, which is awesome to see and awesome to teach, that you want to make sure you got the right simplified radical. Easy way to do it right there. Make sure their decimals match. All right? All right, so we got all 3 sides now. Let's look at all 3 sides. 2 square root of 26, square root of 113, and 3 square root of 5 This triangle has to be what type based on those three sides? 14? Scalene, why?
None of the sides are equal.
Okay, so here we go. Triangle DEF. Let's start using this notation. Is scalene because, what was the reason again?
None of the sides are equal.
Okay. Nope, because no sides are equal. You can put congruent if you want. All right. Notice the bottom of your page, please. Everyone take a look down there. Everybody see the directions for 43. It's just like this one. Leave your answer in simplest radical form, please. Okay, grab a book. Here's what I want because there's way too much time. Grab a book or books for your table. Somebody has a Chromebook out. Open up the classroom and the answer key for day one. Let's go. Let's go. It's not optional.